Last video we looked at creating a bank of sine waves by brute force sending all of the 5 oscillators that we can define to the outputs. There's another way to create a bank of sine tones, and that's using the SineBank. So let's take that and we'll set the frequency parameter of the SineBank to X, and we'll just send that to output. Let's see what happens in this case. This is bank A, so we'll send bank A to output. You can hear a single sine tone is output. Let's bring up a scope. There. A pretty decent sine tone is being output when I do that. I need to do something to create my bank of waves. What I'll do is use the SF parameter, the frequency spread, and set that to a 1. This will create 16 sine tones being output at the normal harmonic spacing of 1 to n. What does that mean? Here, we'll see. I set this to about 100 hertz, and you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 separate sine tones being output at a spacing of, if this is 100 hertz, the next one would be 200, 300, 400, 500, 600 at normal 1 to n harmonic spacing. So I'm getting 16 individual sine tones coming out. And that sounds kind of buzzy because I have all the harmonics in there, and though they're not decreasing in amplitude like a sawtooth wave would be, it sounds kind of sawtoothy anyway. Let's see what this parameter does when I increase it to 2. So I've increased the spread twice as much as I had it before. And now when I play the same thing, setting to about 100 hertz, you can see I have the same 16 sine tones, only now my second tone is at 200 hertz, not at 100 hertz. And like before, they're all being output at about the same amplitude. And I can go up and set that to 4, and it should now do the same thing. There, you can hear the higher harmonics are emphasized here. And there are fundamentals at 100 hertz again, and now the second harmonic is at 400 hertz. Let's go in the other direction. Let's set this to 0.5, and I should see my bass harmonic spacing decreased by half. There we go. There's our 100 hertz, and now the second harmonic is at about 150 hertz. And everything, as you can see, is compressed. All those sine waves are getting closer and closer together. And not surprisingly, the lower tones are being emphasized or less. Let's divide that by half again and see what happens. Let's make it 0.25, and everything should get even more compressed now. There. Things are getting so compressed, in fact, that we're starting to almost hear one tone coming out. Let's go one more, 0.125, and now I should get something where all the tones are almost together. There. Everything is just jammed together. It's kind of hard to hear any individual component anymore. It's just a big mass. In fact, those sine tones are so close in frequency you can even hear all the beating going on. So maybe at setting that low is not going to be that useful in a lot of cases. It could be in some, but that shows you what the spacing parameter does. Let's go and we'll set this back to 1 and get ourselves back to where we want to be. And as we said, the amplitudes of these sine tones are pretty much the same. There's a weighting parameter that we can use, W, that will change that. So when it's 0, the weighting of the amplitudes are even. Let's set this to a 1 and see what happens. Can you see the even amplitudes are starting to descend? The odd ones are still about at the same place, but now here we have 16, 14, 12, 10. I'm tailing off the amplitudes of the even harmonics. Now it's a little confusing because the tooltip of this says 0 to 1 values favor the even harmonics. When it says favor, it really seems to mean favor them being decreasing. What happens if I set that to something like 3 now? You can see the amplitudes of those even harmonics are even further decreasing. And that'll affect the sound. And if I set it really high, something like 9. Now, those even harmonics almost disappear. We still can see the second harmonic and the fourth harmonic a little bit, but the other ones now are tailing off completely. All right, let's go in the other direction. Let's make this negative. So we'll go down, and on the minus line, we'll stick a 1. That would make that a -1. And let's see what that does. And here you can see, as opposed to what happened before, now the even harmonics are staying at that same high amplitude, and the odd ones are descending. And let's do that again. We'll make this say 3. There we go, and like before, now those odd harmonics are really lower in amplitude in that descending pattern. So I can't, in the Sine Bank, individually set the amplitude of any particular oscillator. I can only do it as a group based on the formulas that are available to me. Okay, let's set things back to our kind of default state where all amplitudes are the same. Let's see what happens now if we look at some of the other parameters. The phase parameter, and I've had some online conversations with Lippold on this, the phase parameter is really intended to be a frequency modulation component. So I can take some other oscillator or some other oscillating component like a shape generator and use that to control my phase, and what will happen is I should hear a frequency shift. Let's do something simple. Let's create a shape generator, say at 4 times a second, and we'll set that off on W. And now I'll use a formula. I'll set that to 1, and I'm going to set this to a sine wave component. Set it to shape generator 1, set it to a sine wave. And so I have an LFO here, a low frequency oscillator that I've created, LFO sine wave. And what we'll do, because we're kind of hot on the output, let's create a formula V. We'll make that, say, 0.33, and we'll stick that on the output. And now we're going 4 times a second as the phase input to our Sine Bank. And you can hear that modulation. Let's bring down the amplitude of the sine wave. That might be something that's more useful. And let's bring down the frequency to, say, 1 times a second, a very slow vibrato. You get the idea. You can use that phase input as a frequency modulating source. Now, one thing I can do with this phase modulation is take the frequency spread and make that really low. We saw when we have this off, it's like a sine tone, which in this case would be modulated by our LFO. But let's take this and make it not 0, but some small number, like 0.01. You can hear the sine tones are so close to each other that you get a kind of a shimmering effect now. Which is really nice. And And now let's apply an oscillator on top of the phase that we already have being shifted here. So we'll take a sine tone and we'll feed that in as the phase on this oscillator. I'm doing a really massive frequency shift now in the audible spectrum on top of what I already have. And let me take the LFO off, and I'll just apply this audible phase shift. You can hear it's almost like modulating an oscillator with another oscillator, but I've got a group of them going on here, so it's much more complex than if I, say, just take an oscillator here and feed that into another oscillator as the frequency shift that I'm sending out, say. You can get a kind of a trumpety kind of effect when you phase modulate one oscillator to another. In fact, I don't even need this frequency component on here. And we'll take that away from just an oscillator phase modulating itself to phase modulating this group of sine tones that are very close together. You can hear there's a lot more motion because I'm modulating that group of tones that are very close together. And if I take this off, then I get closer to what I would have had if I was just modulating one oscillator with another, since this is more just a single sine tone. But as I increase that, let's make it 0.1. Now I'm oscillating that group of tones that are getting farther apart. And you can see what the phase modulation here can do for me. Now let's take a look at the SP phase spread that affects the phase of the sine bank and see what that's doing for me. Let's take this down to 0.5 as the frequency spread and bring up a spectrogram. This is another way to look at our spectrum. Now when I play, you'll see lines coming across instead of peaks. There you can see the 16 oscillators, but there's a little waviness to each one of them, and that's that 1 times per second phase modulation, little vibrato that we have going. Let's take the phase modulation off completely and look at our spectrum now. You can see it's much more a straight line now. Let's put back our modulation. But now, let me set this to a 1 on the spread. You can hear it's a much greater modulation that's going on now. The amplitude of that phase shifting is getting greater as I set this phase spread higher. Okay, let's quickly set this to 1 on the frequency spread, and you'll see. Easy to see how the spread of those frequencies is increased now. And if I set my spread now to 2, there you can really see the amplification of that phase spread. Modulation itself is so much greater in amplitude. Now I've set things back, and let's look at these final 2 parameters. The C, center control. 0 means the first oscillator is the center, and 1 means the last oscillator is the center, and this functions with this SA column. That's the amplitude spread in relationship to the center. So what we're saying is 0 means no amplitude scaling of the oscillators, which is our default, and greater than 0 means reduced amplitude of oscillators farther from the center. Let's see what this really means. So what we'll do is we'll keep the center as the first harmonic, set things back so that my amplitudes are pretty much constant through all the oscillators. And now what I'll do is I'll set the SA, that center amplitude scaling, to 1. Since the center is 0, which means the first oscillator is the center, we should start to see a descending scaling of all the oscillators. And that's what happens. Can you see they're starting to descend instead of all being the same? Let's increase that value to 2 and we should be able to see it even more. There, we can even see it descending greater from the center. Now, the high harmonics are being lessened, so you're hearing less of that high frequency component. Let's set this to some really large value like 5, and we should really see something different happening now. Everything is being attenuated, and you can obviously see how that scaling is decreasing from the center. Let's make things opposite. We'll make the center the last oscillator, and now we'll start with 1 and see what that does on the amplitude scaling. The center is now the last oscillator, and I can see my scaling now going in the opposite direction. So my higher harmonics are going to be emphasized, and the lower ones are going to be decreased. And if I make this a larger value like 3, well, there I've kind of attenuated all my lower oscillators, and I can only hear that very high frequency component. That gets kind of out of range if I go too high. So you probably don't want to use very high values on this scaling. Let's set the middle oscillator, 0.5, to be the center, and now let's see what happens. Well, the middle one is around here, and things seem to be scaling off in both directions from the middle. Let's make that a little larger so we can see it a little better. And there you go. It's quite obvious. Center's around here, and we can see that we're scaling now in both directions. So that center frequency is going to come out, and both the lower and the higher oscillators are going to be attenuated. So there you go. That explains all of the parameters that you can use with the Sine Bank. I've created a little test preset for the Sine Bank that I'll include in the Facebook link. This lets you play around with all the parameters, weighting, the spread. You can even set it near 0 to get that kind of oscillating effect. Of course, if you put a shape generator on the spread or some dynamic control in the spread, you can get some nice changing effects of that nature. If you bring in the phase frequency, I have a shape generator, an LFO that's modulating things. You can change the speed. And you can change the phase spread. You can change the center and the amplitude spread on the center. So this will allow you to play around with all the components of that Sine Bank, and maybe it could be useful in and of itself. Let's do one more thing. As we said, we can't set individual frequency components of the oscillators in the Sine Bank. You have to manipulate them as a group based on the functions that are provided. But we can do something creative. Let's take that Sine Bank and we'll send the output of it, bank B in this case, into a BIC mode, where I can individually alter the mode amplitudes. And what I'll do is I'll set the frequency of my BIC mode to be the same as the frequency of my Sine Bank. And then I'll find a sweet spot in terms of the bandwidth that will not create too much resonance. And I should be able to individually now kind of control my frequency components in this Sine Bank. Here's a little more saxy kind of sound. But let's create a ramp of this nature. Let's And we can see, yeah, I can create a ramp down by just changing the mode amplitudes. I'm not fooling around with the sine bank. All I have is my base frequency spread set here. Let's do the opposite. Let's create a pattern more like this. Now I don't want to go past the 16th mode here. I'm on mode 17. Zero that out. I only want 16 modes, and I'll set this pick mode up to be in my 48 bank size so I can get up to 16 of these modes set. Let's see what that does. As we can see, the expected reverse. We could do that by changing center frequency and spread of the center frequency on the sine bank, but what the sine bank doesn't let me do is stuff like this. We'll create a profile, but if you listen, I can now individually control those mode amplitudes, that spectrum of my sine bank. And I can create a much greater set of timbres in a kind of additive synthesis style by sending my sine bank in through a BIC mode and directly manipulating my mode amplitudes. I can even set an offset, as I've done here, to maybe take a little bit off of the lower harmonics that might come out a little bit too much. So there you go, the sine bank. Lots of different ways to apply it. Ed has a number of presets that you can go and look at that use it. If we go to synth here, I believe there's a sine phase preset that uses that group modulating effect that we talked about. Lots of different things you can do with the sine bank.